and welcome to the second and final video in this project. I'm building this mitre cornered box using simple hand tools only. By the end of the first video we'd cut the mitres, sized the lid and made the initial assembly of the basic box frame. I'm starting the rest of the project by dimensioning the base. I'm using a piece of 4mm or 1/8 of an inch ply that I had lying around. I offer up the ply to the job, matching a good right angle corner to one of the right angle corners of the box, and then measure and mark the width. Using the knife mark as a guide, I use a tenon saw to cut the width. It's more efficient to use a saw end to end to make a rip cut by holding the ply in the vise, but this way I can guarantee a nice straight edge. I offer up the ply to the job again, ready to mark the length. I saw the ply as before. I cut on the waist side of the line to make the piece deliberately long. I then use my plane to make small adjustments and bring the piece down to the exact required length. Having fitted the base, I mark the orientation for later reference because I'm not going to glue it in quite yet. First I'm going to fit the splines. The material I'm using for the splines is the walnut that was left over when I cut the lid to width. I don't want the splines to breach the inside faces of the box, so using my combination square I look for a place where I can position a 45-degree angle without that angle breaching the inside of the box. I then mark in where that angle meets the outside face of the box. If I've marked the angle correctly, the distance between the corner and the mark should be equal on both faces. I set the overhang on my combination square to this distance. I can now use the square to mark in the outside angle of each spline on each corner of each face. And that's everything marked up. I lay the spline material on the box to get some kind of idea as to the positioning. The exact placement of the splines is an aesthetic decision. However, we're using splines for a sound engineering reason. A glued mitre joint is not inherently strong, so the splines provide a mechanical element to the joint which reinforces it. I decided I liked the positioning where the distance between the bottom and the top of the box and the spline was the same width as the spline itself, so I set my gauge accordingly and mark in the outside edge of each spline around each corner of the box. Having marked the initial positions along the top, I flip the box and do the same for the bottom. Next, using some of the spline material as reference, I want to mark in the width the spline recess needs to be. Having made this mark, I then reset my gauge. I've deliberately made the marking slightly tight as I don't want the splines to be sloppy within the recess, and it's a fairly trivial job to take a little bit of thickness off the splines to get them to fit. As before, I work round all the corners and mark in this second mark. With everything marked up, I now need to mark in the outside edge of each spline. I do this using the original line as a reference and using a square and marking knife. As with the gauge marks, I want to make this knife mark fairly well established, as these are going to form the edges when I chisel out, so I want them to be nice and sharp. I repeat this process around the entire box. And with everything marked up, each corner looks a little like this. I put some paper tape down the outside edge of each spline. This is to help protect the surface as I work. The first job is to saw across the corner. I saw on the inside of each of the spline position marks. The two saw cuts need to be parallel. The end of each saw cut should stop just shy of the paper tape. I then use a chisel to remove the material between the saw cuts. I work into the corner, maintaining a 45-degree angle with the face of the box. To ensure that the outside edges are crisp, I'll slightly deepen the initial knife mark using my chisel. I work fairly gently at first because I don't want anything to tear out. I'll work into the corner from both edges, flipping the orientation of the box as needs be. I have a better view of the saw cut now that it's on the top face, so I just use my saw to finish off the cut. Use the chisel to re-establish the marks, and then work into the corner from this side. There's much less worry about tear out working now in this direction, as I've already removed the material from the other side. I take my time on this job because I want it as neat and accurate as possible. I'll keep changing the orientation of the box in the vise so that I can work in from both directions. I'll keep going until I've got a nice 45-degree angle where the base of the chisel lies flat at 45 degrees to each face and also reaches the edge of the paper tape on both sides. The spline then gets fitted in this gap in this kind of position. I then repeat this process on all the corners of the box until all the spline recesses are cut. And we end up with something like this. Next I cut all the splines to length, and at this stage I ensure that I collect some of the sawdust because I'm going to use that later. I need 8 splines at this stage in the build, although there will be a total of 12 in the finished job. I work round the box, test fitting a spline in each recess. I'll custom fit each spline as, even though we marked things up as accurately as possible, there'll still be some inconsistencies. Where a spline proves to be too thick for the gap, I'll simply remove a small amount of material using sandpaper. I can then refit. When I'm happy my splines fit, I can glue them in place. I add some glue and then spread it out with a popsicle stick to make sure each side is covered. I then fit the spline and press it into place. I'll repeat this with all the splines on the box. And then leave everything to dry. There's no need for clamping here. When the glue is dry, the splines are nice and solid. The next job is to remove the excess of the spline. I do this by sawing down parallel to the face of the box. A tenant saw isn't the recommended tool for this kind of job, as there is a possibility for scratching the surface of the box. This is why I added the paper tape. Usually it would be recommended to use a flush cut saw such as this. However, I wanted to stay on brief and use only those basic hand tools. So actually, with a bit of care and with the addition of the tape, I found that the tenon saw did the job just fine and didn't scratch the surface. I did, however, make sure I left a slight gap between the surface of the box and the saw cut. I repeat this process across all of the splines. To finish the job and neaten everything up, I use a chisel. I work in from the corner towards the inside of the box. If you work from the inside towards the corner, there is a danger of tearing out the material. I use a slicing motion on the chisel. Holding the base of the chisel flush with the surface of the box ensures that we can get everything nice and flush. Finally, I use a plane with a very shallow set in order to get everything nice and flat. Again, I work into the middle from the corner. And that's all the splines finished off. There were one or two mistakes though. I managed to chip off the corner on this spline, and this one has a gap behind the spline. Both of these mistakes are easily remedied. Firstly, to repair the chip out, I just glue on a new piece of material. I tape it in position while the glue dries. Next, to fill the gap, I'm going to make some filler that will match the splines. I take some of the sawdust which I saved earlier when I was cutting the splines to length and mix it with some wood glue. I then use this mixture to fill the holes. Then I leave everything to cure. Once the glue has hardened, I can cut off the excess from the patch in the same way as I cut the splines. Firstly, using the saw, and then using the chisel to get everything flush. The excess of the filler I remove using sandpaper. And there we go, two nicely repaired corners. The next job is to remove the lid from the box. I'm going to do this by cutting all the way through the box. I want the splines in the corner of the lid to end up being centred between the top and bottom, so I measure the gap from the top of the box down to the spline, and then duplicate this distance from the bottom of the spline down to where I need to cut. I set my gauge to this distance so that I can make the mark for the cut all the way around the box. Using a steel ruler and a knife, I make the initial mark deeper. This will help when it comes to sawing. First of all, I want to deepen my marks to guide the saw, so I put the saw blade in at a slight angle to the line and start to cut. As it starts to bite in, I bring my saw up so it's perpendicular to the face and take a few more strokes. In order to ensure a perpendicular cut, I'm going to use this scrap piece of timber with a straight edge to act as a sawing guide. I clamp it to the box so that it is directly parallel with the cut mark. Then, by pressing the saw plate against the side of the guide, I can ensure a perpendicular cut. I'm going to keep sawing in this fashion until I've gone deep enough to get through the side of the box. That's deep enough. And we have a nice straight cut. I then flip the box and do exactly the same on the other side. Initially starting sawing at an angle, and then bringing the saw perpendicular to the side of the box. I then fit my guide to finish off the cut. I rotate the box in the vise so I can cut the ends of the box. I don't use the guide for this because the cut is already established and straight from when I cut the sides of the box. As I cut, I ensure that the saw is perfectly in line with the cuts on the side. At this stage, I do not want to cut all the way through this edge of the box. I test the depth there. What I'm looking to do is cut about 3/4 of the way through at this stage. I then flip the box in the vise and do the other end in exactly the same way. That's all looking pretty good, with the cuts all nice and square. If I was to cut all the way through the end of the box in one go, the vise would nip the two sides together and the cut cross section would no longer be square. So, before I go further, I pack out the gaps in the side of the box using some card. This packing will help to keep everything square as I cut through the remainder of the box end. Having no bottom on the box at this stage means that I can use my fingers just to feel whether the saw has broken through yet. And that's through. I then put some packing in this end of the box, flip it in the vise, ready to make the final cut in the other end. Once that cut is finished, I can remove the box from the vise, and the lid and the frame of the box are now separate. Cutting the lid from a box is a tried and tested way of ensuring that the lid and box fit precisely. It's a lot easier than trying to make the box and the lid as separate jobs. It also means that the grain pattern between the lid and the rest of the box matches in a pleasing way. I mark up the orientation of the lid for future reference, because despite our efforts to make everything square, there's only one orientation which fits perfectly. Next, I'm going to finally fix the bottom of the box. First, I add some glue to the inside of the box. Again, I've used some paper tape here to make cleaning up of any glue squeeze out easier. I then push the base of the box in position and leave it to set with an improvised weight to hold it in place. Once the glue is set, I can remove the paper tape and clean up any remaining squeeze out. Now that the lid has been removed, I can turn my attention to the extra splines. I want these extra splines to be along the top of the box section. This further reinforces the corners and also looks very pleasing. I want the splines to be set in from the top of the box section at exactly the same distance as they are set in from the bottom. So I set my gauge and repeat the whole process I used to fit the first 8 splines. And we now have all our splines fitted. Next, we need to do something about the lid. We want the lid to stay in position when it's closed, and we're going to achieve this by using some more of the plywood to make a lining for the lid. First of all, I need a straight edge on the plywood, so I use a plane to make sure I've got this. I'm going to need 4 strips of plywood. I want the strips to be approximately twice the current depth of the lid, so I mark up these strips on the piece of plywood. And cut them to length. I'm using the same method here for cutting to ensure I get a nice straight cut. It's not really the correct way to use a tenon saw, but I find that it's particularly effective for this. A more common approach would be to rip down the material by cutting like this, and I use this method to do the end pieces. When I have all 4 pieces cut, I bundle them together put them in the vise and use a plane to make sure that all 4 pieces have straight edges and are all of equal height. The linings are going to go on the inside of the underside of the lid and will meet at the corner with mitre cuts. The first job is to put a 45-degree mitre in one end of each of the strips. Once again, I use the mitre jig to do this. The strips will fit into the corner like so. I need to cut the strips to length, but I also need them to have a 45-degree mitre at the other end, so I mark up the required length of the first strip. I then place a mitre guide in my vise ready to make the cuts. These mitre boxes are very cheap to buy and very useful, although you can make your own quite simply. You just need 2 straight pieces of wood set at a 90-degree angle with some accurate 45-degree saw guides cut into the upright. Holding the workpiece in position, I cut the other mitre. I can then test it in position, and that looks good. I'll repeat this process with the other pieces. As with most of my woodworking, I like to bespoke cut pieces to fit the job, rather than measuring everything up beforehand and cutting to that measurement. This piece looks a little bit too long, but that's not a problem. I can simply use the mitre jig again, just to take off a little bit more material. I repeat these steps for the other 2 sides, switching between sawing on the mitre block and using the jig as necessary. With everything in position, the lid should fit onto the box, just like this. And they hold the lid nice and secure. Next, I just need to glue these liners in position. If everything is cut correctly, there shouldn't be any need to use clamps here. The liners should hold each other in position. If you find the pieces bowing slightly whilst in position, it's because they're a little bit too long. While that's gluing up, I'm going to prepare some finishing touches. I'm going to need a couple of short pieces of dowel, which I'm going to make out of some of the remaining walnut. First of all, I cut a square section to the approximate diameter required. I want this dowel to be about 8 mm in diameter, so I'll mark this up roughly using a drill bit. I'll remove the excess material using a chisel to get the dowel to roughly the right size. A recognised way of making a dowel would be to drive the peg through an appropriately sized hole in a piece of steel. Unfortunately, I don't have anything suitable to hand. Also, I only need a short piece because I'm going to use it for decorative rather than structural reasons, so I'll use a piece of sandpaper to get things to more or less the right diameter. I check my finished piece against the drill bit I'm going to use to make a hole for it. The glue in the lid liner is now set, so it's time to fit the lid. It fits quite well, but it's perhaps a little tight. So I'll use some sandpaper to round off the corners of the liner and also take off a small amount of material. And that fits a lot better now. Now, despite our attempts to make sure everything is nice and square, the lid doesn't fit in both orientations. It's not far off, but just enough to stop it fitting. So this is where the dowel comes in. I'm going to use it as a decorative feature to indicate the correct orientation of the lid. First of all, I find the halfway point on the front face. I then mark the point which is exactly halfway down the lid. I take this measurement and mark the same distance down from the top of the box. And using a centre punch, I mark these positions. These marks are nicely in line. Next, using my hand drill, I'm going to cut into the surface of the wood. I'm using the drill bit which matches the diameter of my dowel. Referencing the marks made with the punch, I'm going to drill down on both of these marks down to a depth of about 2/3 of the thickness of the wood. I then cut 2 short pieces of dowel. I place the box in the vise for stability and add some glue to these holes. And then carefully press in the 2 pieces of dowel. I wipe off any excess glue and then leave everything to dry. When the glue has dried, I add some paper tape to protect the front of the box. I then saw the excess material off of the dowels in the same way as I did with the splines earlier. And once again I use a chisel to tidy everything up. Working with a slicing motion as opposed to a chopping motion. I work my way around the dowel so I can approach it from each side. I deliberately take my time over this to make this feature as nice as possible. With the chiselling done, I can remove the tape. I'll remove the pencil lines with an eraser and then sand everything so it's perfectly flat. I want to round off the sharp edges of the box, and normally I'd use my block plane for something like this. However, sticking with the brief of only using things in a basic toolkit, I'm going to use my number 4 smoothing plane. It's perfectly feasible to use a plane of this size on a job of this size. I take the plane and run it along the sharp edge. I then alter the position of the plane relative to the corner and chase the new edges round the corner. I repeat this until the corner is nicely rounded and feels nice to the touch. I've made sure that my plane is nicely sharpened, and I'm very careful when I get to each corner so as to avoid breakout. I repeat the process on all the edges of the box. And that's very nearly finished. Before we add the finish, I'm going to give everything a good sanding. I start by easing over the corners just to make it less sharp and more comfortable to handle. I then sand the rest of the box, taking the opportunity to ease over any sharp corners, such as the inside of the lid. Because we spent a lot of time with the plane and card scraper when we first cut the sides of the box, it doesn't take a huge amount of sanding. Finally, I round over the bottom edges of the box. This just requires a few passes along each side. I then give everything a good rub with a cloth to get rid of any dust. And then it's time to add the finish. I'm going to start by using Danish oil. I pour some into a small glass jar. Danish oil goes off quite quickly with air, so the less time the cap on the bottle is off, the better. So I found it's better to dispense some into a jar rather than to add it from the bottle itself. I use a cloth to add a decent amount of Danish oil all around the box, and then I'll wipe off any excess to stop any pooling. It's at this point that you can really start to see the figure in the walnut come through, and also how nice the splines look against the lighter coloured beech. I add a good coating of oil all around the box, inside and out, and then leave it to dry for at least 24 hours. Once dry, I give all the surfaces a light sanding. And then add another coating of oil. I repeat this process 4 times in total. Before the final coat, I rub everything down with a very fine gauge wire wool. I then apply the final coat using the wire wool. And once everything is dried, the finished box looks like this. I hope you've enjoyed this project and found the videos useful, and if you have, check out our channel and hit subscribe to keep up to date with new projects.